Yes, good evening, senior fives. We are having a lesson here about projectile motion. So it is about projectile motion, and in projectile motion, it is actually a simple topic that every learner should have at hand if he is to secure some marks. Yes, under projectile motion, we shall study the different things under projectile motion. It is not so bulky that you shall only study about the definitions of terms. After knowing the definitions of terms, you need to know the derivations. To knowing the derivations, finally, we just talk about the calculations. So these are the different things to be tackled under projectile motion. Simply, we shall begin with the word a projectile itself. Members, for those who understood properly motion under gravity, then projectile motion is just going to be simple. For motion under gravity, we didn't see any angle, but in projectile motion, bodies are going to be projected at a given angle. For example, I can throw a ball. For example, let me take a throw of this stone. I can throw it at that point, then I project it in that way. So in that way it has gone, but for it to go, I know its speed, then I know the angle with which it's making the horizontal together with the vertical. So in simple terms, a projectile is anything or any body which is given an initial velocity and left to move on its own under the constant force field. For example, this is a motion to be circular. This is a body at this point. It is given an initial velocity u and left to move maybe from this point A up to this point B. Maybe this is the velocity, initial velocity u with which it was projected. It is moving along on this path A. It is from point A, this is the initial point of projection. Then point B is a point, the final point in which the particle lands. So a good physicist, just like is a good mathematician, you can be able to distinguish these two components. We have the y component here, and then I have here the x component. It means that since velocity is a vector quantity, I can easily always get the velocity along the x-axis. I can also get the velocity along the y-axis, given that the angle theta described is given like that. When you look at this projectile from point A to point B, this is the maximum point reached by that projectile. Maximum point reached by the projectile. Then this is the point of line of projection. This line here, I'm calling it line of projection. This is the point of projection, and then this is the line of projection. So from this point A to point B is the displacement covered on the x-axis, and it is called range. So this distance between the maximum point reached, or the highest points reached, and the line of projection is what we call maximum height. So several definitions here will arise. Like for example, they can tell you to define point of projection. 2, they can ask you to define the term angle of projection. Besides that, they can also tell you to define maximum height. Then besides that, they can also ask you to define range. They can further ask you to define time for flight. Then finally, they can ask you a definition of the term trajectory. Now members, pay attention. Here you are seeing that this body is being projected from point A up to point B. But this is a path, it is going freely under the influence of gravity. That's why we said a projectile is a body which is given an initial velocity and left to move on its own under the constant force field. That question is different when they say define a projectile motion. Members, a projectile motion, this refers to a motion which is described by a body given an initial velocity and left to move on its own under a constant force field. Yes, so those are the first definitions of terms. Then when I consider such a drawing, I've told that this is initial velocity u, this is the maximum point reached, this is the line of projection, this is the point of projection, this is the angle of projection, this is the y component or y axis, and then this is the x component, also called the x axis. Maximum height. Maximum height is the distance or the length between the maximum point attained by a projectile and the line or the horizontal line of projection. Then angle of projection. Angle of projection is the angle between the horizontal and the direction of projection through the point of projection. Time for flight. Time of flight is the time taken by the projectile to move from its initial point of projection to its final point of landing through the point of projection. Then you also have this one, which is called trajectory. Trajectory is the path described by a projectile. Then we have range. Range is the distance covered by a projectile horizontally from its point of projection to the point it lands, but horizontally. So having known that, then you are liable to now carrying out the derivations. Remember, when you come to derivations, the first one is how to derive the derivation of maximum height. Remember that in the motion under gravity, we had the same things. In first, we could derive the maximum height, time taken to reach the maximum height, and then time for flight, then velocity with which the ball or the object hits the ground. Let me start with maximum height. For me to derive maximum height, members, we follow the third equation of linear motion. V squared is equal to u squared plus 2as. Because I want to consider maximum height, at this maximum height, the maximum point here, the final velocity is 0. Hence, I'm going to have here 0 squared is equals to its initial velocity. Since I am taking the maximum height, which is vertical, then I'm going to bring this velocity to the vertical. Then this, because this angle is opposite the vertical axis, then I'm going to use sine. Therefore, this is u sine of theta, but this is square. Because I'm ending on maximum point, that body will be opposing gravity. Therefore, I'm going to put minus 2gs, where s now becomes the maximum height. Members, when I call like terms, this is 2gh max is equal to u squared sine squared theta. When you make h max the subject, my h max is equal to u squared sine squared theta over 2g, and that is the expression for maximum height. It should be taken with much concern. Then the next derivation there is time to reach maximum height, which can also be called T max. For T max, members, we use the first equation. V is equal to U plus A at At maximum point, V is 0. My initial velocity is resolved to the vertical, and this one becomes U sine of theta. Because the ball at that point will be opposing gravity, then A becomes minus G, and this thing becomes now my T max. When I make T max the subject, my T max is equals to U sine of theta over G, and this is the equation of time to reach maximum height. Then total time for flight. We are considering the whole motion from this point A to point B. When I want to get the time for flight, I'm going to consider the second equation. S is equal to ut plus a half at squared. But I'm now considering the displacement on the y-axis. The displacement on the axis is going to be 0, because this one moved from point A to some point. Then from this opposing its own real displacement, then displacement on the x-axis is 0. Bring the velocity on the x-axis, bring it to the y-axis, because you are considering that it becomes y u sine theta, then times now t. Then the acceleration here is going to be a negative, so it now becomes now becomes minus a half gt squared, where capital T represents time for flight. Hence, if I want to make T the subject, you pull out T into u sine theta minus a half gt. So we say that either T is equal to 0 or u sine of theta minus a half gt is equal to 0. Hence, now my u sine theta minus a half gt is equal to 0. U sine theta is equal to a half gt. Hence, T is equal to 2u sine theta over g, and that is the total time of flight. That is only true for a projectile which is being projected on a level ground. You realize that time to reach maximum time for flight is 2 times the time taken to reach maximum height, and this, members, is only true for a projectile which is on a level ground. Before we summarize, there is this one also called range. Range, this is the distance covered horizontally. Still, we use the second equation, s is equals to ut plus a half at square. Distance on the x-axis, we are calling it the very range. Bring the velocity on the x-axis becomes u cos of theta. This is multiplied by t. Horizontally, acceleration is 0. So this is going to be plus a half times 0 times t squared. My range is equal to u cos theta. This t means time for flight, so I replace for time for flight times 2u sine of theta over g. R is u times u, I get u squared. This is 2 cos theta sine of theta over g. Briefly, when we go to double angle formula, this 2 cos theta sine of theta means sine of 2 theta from double angle formula. Hence, my range is given by u squared sine of 2 theta over g, and this is the expression for range. When I want to get the expression for maximum range, which is denoted by R max, R max is equals to u squared over g. This is obtained when theta is equals to 45 degrees. Hence, sine of 2 theta will be 1, hence giving us this expression for R max as u squared over g. Members, besides that, we've said that a trajectory is the path described by a projectile. I want to therefore derive the equation of trajectory. For me to derive the equation of trajectory, I have to know that equation of trajectory relates majorly 4 things. It's going to relate the initial velocity, it's going to relate the distance on the covered on the x-axis, relate distance covered on the y-axis, and then the angle of projection. So when I know that is going to relate all this, we are going to consider now distance covered on the x-axis. Distance covered on the x-axis, x is equals to, from the second equation, s is equals to ut plus a half at squared. Hence, my distance covered on the x-axis, I'm calling it x. Bring this velocity on the x-axis, it becomes u cos of theta multiplied by t. We earlier on said that horizontally acceleration is 0, so it is plus 0. Hence, x is equals to u cos theta times t. When you make t the subject, t becomes x over u cos theta. Then from there, you also consider that displacement vertically. When we consider that displacement vertically, we are going to see that the displacement from s is equal to ut plus a half at squared. So this is going to be y. Result of the initial velocity to the axis becomes u sine theta times t plus a half gt squared. Because vertically the ball will be opposing gravity, it becomes now u sine theta times t minus a half gt squared. Replace for this value of t in this equation. Y now becomes u sine of theta multiplied by t, of which t is x over u cos theta minus a half gt. T, we have said it is x over u cos theta, but this is squared. This u will cancel with this u, then I remain in sin theta over cos theta, which gives me tan theta. So my y is equal to x tan theta minus a half, this is gx squared u squared over cos squared theta, and this is the first equation of trajectory. This is one of the equations of trajectory. You can complete through mathematics. We very well know that 1 over cos squared theta is sec squared theta. Hence it can also turn as y is equal to x tan theta minus gx squared over 2u squared. This is sec squared theta. But also members know that sec squared theta is 1 plus tan squared theta. Hence y is equal to x tan theta minus gx squared over 2u squared into 1 plus tan squared theta. Thank you.